The J-36, often touted by Chinese state-controlled media as a revolutionary leap into sixth-generation fighter jet capabilities, is more accurately understood as a deeply flawed product of a political system that prioritizes image, projection, and control over genuine engineering achievement and battlefield effectiveness. The development of this aircraft serves as a case study in how centralized planning, lack of transparency, and technology shortfalls converge to produce an expensive, overhyped, and strategically unreliable weapons system that is unlikely to deliver on its promises under real combat conditions. China has a long history of exaggerating the capabilities of its military assets, and the J-36 fits that pattern perfectly. Despite ambitious claims regarding stealth, supercruise, AI-assisted combat management, and network warfare capabilities, much of what has been presented to the public is unverifiable and built on state-manufactured narratives rather than evidence-based performance. No open trials, international collaborations, or credible third-party evaluations have been allowed to take place. The absence of these mechanisms suggests not superiority, but weakness, an implicit acknowledgement that the platform may not withstand scrutiny. In contrast to Western programs, which involve years of testing, public hearings, and independent oversight, China's approach revolves around concealment and control. This makes any claims about the J-36's actual performance highly suspect. One of the foundational weaknesses of the J-36 is the ongoing failure of China's aviation industry to develop reliable high-performance jet engines. For years, China has attempted to close the gap with Western manufacturers like Pratt & Whitney and Rolls-Royce, but the results have been consistently underwhelming. Despite public announcements and short-term prototypes, none of China's domestic engine programs have produced long-term, battle-proven, fuel-efficient engines that meet modern operational demands. The J-36 reportedly relies on a three-engine configuration, which by itself is an indication of technical underdevelopment. A tri-engine design adds complexity, weight, and maintenance challenges, and is typically avoided in high-end military aviation because it makes the aircraft more vulnerable to mechanical failure and harder to support logistically. This is not a design breakthrough, it is a workaround for engineering deficiencies. The implications of this design flaw are serious. High fuel consumption reduces operational range and time on station, especially in a theater like the Indo-Pacific, where long distances over water are common. Maintenance demands increase exponentially with each additional power plant, and the requirement to service three engines rather than two puts greater strain on logistics and readiness. For a country that has yet to demonstrate large-scale, high-readiness deployments of fifth-generation aircraft, introducing a more complicated platform like the J-36 without a robust maintenance infrastructure only increases the likelihood of downtime, performance degradation, and failure in critical moments. Beyond engines, the aircraft's shape and aerodynamic characteristics are another area of concern. The tailless, flying wing design that China appears to have adopted introduces serious stability challenges. While such a design may help reduce radar signature, it comes at a steep cost to maneuverability and low-speed handling. These issues are particularly acute during carrier operations, where slow speed control, precision landings, and resistance to turbulent airflow are essential. China's aircraft carriers, still relatively new and limited in capability, are not well suited to support such an experimental platform. Without decades of naval aviation experience and a fully developed catapult-based launch and recovery system, the operational deployment of the J-36 from sea platforms remains more aspirational than practical. The aircraft's design may look futuristic, but without the necessary underlying infrastructure and human expertise, its potential remains locked in theory. Then there's the matter of electronics and software. China claims that the J-36 is built around advanced avionics, electronic warfare systems, and AI-supported combat management. However, the actual sourcing and development of the microelectronics behind these systems remain highly questionable. Due to sanctions, export controls, and internal industrial limitations, China does not currently produce the same grade of high-end semiconductors used in Western military aviation. These chips are essential for mission computers, sensor fusion, targeting systems, and electronic countermeasures. Any weakness in this area reduces not only the fighter's capability but its survivability in contested airspace. Software reliability, cybersecurity, and redundancy, hallmarks of Western aircraft, cannot be assumed in a platform developed under secrecy with restricted access to top-tier components. This problem is compounded by the authoritarian structure of China's military-industrial system. Engineers and program managers operate under immense political pressure to meet targets, deliver milestones, and project strength. This environment suppresses honest feedback, inflates testing results, and promotes conformity over innovation. Mistakes are often buried rather than corrected. Development cycles are driven by political calendar demands rather than technical readiness. The J-36 program, like many others in China, is less a response to strategic need and more a symbol of national pride designed to impress external rivals and domestic audiences alike. But pride does not make up for unreliable engines, underdeveloped control laws, or untested avionics. There is also a strategic downside to deploying an aircraft like the J-36 in its current form. If the platform is introduced into frontline service before it is truly ready, it risks exposing its weaknesses during peacetime operations or exercises. Once those weaknesses are known, adversaries can exploit them systematically. China is effectively putting itself in a position where its most publicized platform could become its most vulnerable. This is a dangerous proposition for any military, particularly one that has not fought a major air war in modern history. Over-reliance on an unproven system also means other critical areas, pilot training, logistics, doctrine, may not receive the attention and funding they deserve. The illusion of technological superiority can easily mask institutional fragility. The J-36 is not a breakthrough but a distraction. It represents the culmination of decades of centralized military planning, foreign reverse engineering, and overpromising. Its public unveiling serves political ends rather than strategic ones. Its design reflects compromise, not innovation. Its development is driven by ideology more than physics. In the end, what China has produced is not a war-winning platform, but a vulnerable system surrounded by exaggerated claims. The aircraft may never be ready for real, sustained conflict against advanced adversaries operating in complex joint environments. In the most likely scenarios, the J-36 will struggle to compete not because it is underfunded, but because it is built on a foundation of systemic inefficiencies, technological immaturity, and political theater.